Hi guys, and welcome to another video. This video in particular is just going to be talking about exact values. I'm not going to go too in depth about what the exact values are. What I'm going to be focusing on more in particular is actually applications of them and actually, solving questions using these exact values. So actually applying sine, cos, and tan and the degrees and using these surds and using these exact values in questions and substituting them in instead of finding a number that has decimals in it and rounding like you normally would in a calculator. How we would solve those questions in like an example where you don't have a calculator and they're asked to give you the answer in exact terms. Okay, so let's just get straight into it. So the screen at the moment you can see is just a table. This is a very common table that you would see all the time. This is a really good reference for the different values. It's recommended that you remember it, especially if you are in math methods in year 11. So this is for the Western Australian curriculum. It is really recommended that you remember these numbers. It does take some time to remember, but before you know it, the more you use it, the more you remember. Okay, so and some patterns that you might want to look for are this one here and this one here. So you can see that sine 30 is the same as cosine 60. Another pattern that you could probably look out for is this root 3 over 2. That's the same as sine 60 cosine 30, so just the inverse. And also you can see that middle two here are actually the same as well. So kind of think of it as the opposite. So sine is the opposite to cosine, like they kind of switched. Like this one here is here. I'm gonna have to use all my colors now. So you can see that this is also the same as this. You see what I mean? Like there are a few patterns that can help you remember it. For those who kind of feel a bit anxious about remembering all of these numbers, they are just the inverse of each other. 10 is just a bit different, where they've got, it's kind of like 0 to 1 to suddenly undefined. So it's just finding patterns within that and actually being able to use those for the following questions. So let's just dive right in, using this exact values table, to solve some questions. All right, so let's have a look. So this is a basic example. This is a regular right angle triangle. So you don't need to use cosine or sine rule. I can straight away technically use just regular trig using sine, cos, and tan. And normally what we would do is we'd label the sides, we'd find it, we rearrange the equation, put it into our calculator and get a number and round it. So in this case, what I would do is like, oh, this is my theta, this is my opposite, this is my hypotenuse, and because it's SOHCAHTOA, I'd know straight away that it's sine. So I'd go sine 60 is equal to 9 over x, right? That's what you would normally do. Then you'd rearrange it, so you get 9 over sine 60, and I'd put that in my calculator and actually find that answer. But we're not doing that today. We're actually going to be using the exact table's value. So I'm going to keep that top part here because that's basically what it is. You're still using sine and you're still finding the opposite and hypotenuse and still rearranging, but instead for my sine 60 I'm actually going to substitute it in. I'm actually going to substitute this value here. There's a root 3 on 2, right? So going to root 3 on 2 is equal to 9 over x. And so now you're kind of like, well, now what? You can see that we're trying to solve for this, and whenever the unknown is on the bottom, I like to just flip it. So if I flip one side, I flip the other. So I'm going to just do that really quickly now. It's equal to x over 9. So this is good. So what I'm going to do now, I'm just going to multiply both sides by 9. So I'm going to get 18 over root 3 is equal to x, which is great and all, but we want to rationalize the denominator. And I've actually talked about rationalizing the denominator in another video, in my surds basics video. So if you want to check that out, go free to check it out. But you can see here that I want to have that surd not on the bottom, not in my denominator, but instead on the top. Okay, so I'm going to put this onto this side here. I'm going to use red just so you can see what I mean. So my answer here, I'm just going to rewrite it here, is 18 over root 3. The way I get rid of it is that I times the bottom as well as the top, so the numerator and denominator, by the surd that I've got on the bottom. So in this case, I've got a root 3 on the bottom. I'm going to multiply the top and the bottom by root 3. Okay, you might be like, oh, well, that changes everything. You're changing. You can't just add numbers in. That's what you're told all the time. But you can, because technically speaking, right, this is the same as like, for example, 3 on 3, which is equal to 1. And anything times 1 is itself, right? So root 3 over root 3 is just 1. We're just multiplying it by 1. We're just slightly manipulating it. That's all. So what I'm going to do is I'm going to actually put this here. So I got 18 root 3. And now what we're going to do is we're going to have this multiplied by this. And this is one of those surd laws where if you multiply a surd by itself, it just becomes 3. Okay? So we're almost there. All we need to do now is just get rid of that bottom part here. We can simplify this and this. That goes into itself once, it goes into it 6 times, and we have 6 root 3. Super easy. All right, so that's one example that I've got there. All right, so let's try an example where there's 2 triangles involved. It's not that difficult. It's just kind of applying the same concept twice. So don't make it such a big deal. Just think of it just very plainly. The start doing it. So we've got an x here. So we want to try find x, and we need to know this side because we can't really apply any trig functions or anything yet because we don't know what that is. So we've got 2 unknown sides. So to find that unknown question mark side, we've got an angle. So it's my theta, this is my hypotenuse, and this will be my opposite because it's directly opposite it. So using SOHCAHTOA, I know that sine is going to be involved. So sine 45 is equal to my opposite, which is, well, let's just say it's y. I'm going to name that y actually, divided by 10. I'm going to convert this into exact value form, so getting the answer from the exact values table from earlier. So that's just going to be 1 over root 2 is equal to y over 10. Timesing by 10 on both sides, I'm going to have 10 over root 2 is equal to y. I'm not going to rationalize the denominator yet because I'm not quite at the end of my question. At the end I will. But for now, I'm just going to leave it. And so I'm going to apply it to my next triangle. So the second triangle here. So I now know that y is 10 root 2. So let's now start it off. So we've got our opposite, which is what we're trying to look for, which is x. And then we've got our hypotenuse. Remember, this is the longest side. This is not my adjacent. So that's my hypotenuse. So we're going to do sine 60 is equal to my x over 10 root 2. The way we can fix this up is just basically flip it is equal to root 2x over 10. For those who are curious about how to do that, this is basically the same as x over 1 divided by 10 root 2. And because that's just fractions, and when we divide fractions, we flip it and make it a multiply. So that just becomes x over 1 times root 2 over 10, hence why that is so. So for those who are curious, sometimes it's a bit hard to understand with a lot of algebra or basic stuff going on, and sometimes people go through it too quickly. So that's where that's come from. So I'm going to convert this sine 60 now to its exact value form. That exact value form is root 3 on 2. It's equal to root 2x over 10. I'm going to multiply both sides by 10 just to remove the denominator. So 10 over root 3 divided by 2 is equal to root 2x. So that becomes 5 root 3. So I've just basically cancelled that out, is equal to root 2x. Now what I'm going to do is I'm just going to divide by root 2 on both sides. So now I've got 5 root 3 divided by root 2 is equal to x. So this is where I'm like, well, I found the answer now. I've got x on its own, but now I kind of just need to rationalize the denominator. So instead of doing up here, I'm just doing it at the end. Okay, so I'm going to make it in blue now. This is our final step now. So x is equal to 5 root 3 divided by root 2. So for those who don't know how to rationalize the denominator, again, like I mentioned earlier, just go check out the other video for it. But you're basically multiplying it by root 2 on top and bottom. So when we do this, this is the same as 5 times root 3 times by root 2. Based on that third law that I talked about in the other video, that's basically 5 root 6. I've basically multiplied what's inside both of those. So 5 root 6. and then we do root 2 times root 2. That's the same as just 2 on its own. And we can't simplify it any further, so that is actually our final answer for that question. Easy peasy. Alright, I'm going to stop this video here. I'm going to make a part 2 for another few questions just to finalize it a little bit and do some proofing as well. So if you're interested in that one, just go to the next video. Thank you.